Welcome everybody here in the room at the Kokusai Bunkakaikan in Tokyo and online. Thank you so much for joining us for this second installment of the Future of Energy and Climate Seminar Series, jointly hosted by the Asia Society Japan and OIST, the Okinawa Institute for Science and Technology. Very honored to have you here. And now, without further ado, I'd like to open the program, and I would like to give the stage to Dr. Peter Gruss, who is the President and CEO of OIST, of the Okinawa Institute for Science and Technology. Peter.
Well, thank you very much, Jesper. It's an honor to be here today. And we gathered here because we share the common belief that climate change is the biggest threat of our century, enhanced even further by political turmoil, resulting, at least for the Europeans, in a cut down of the supply of natural gas, ironically replaced by coal and other fossil fuels. Societies are critical of atomic power. The perspective of fusion power is unclear. There are not enough sustainable energy providers. This is quite a mess. So we need guidance and answers. And it gives me great pleasure to introduce Sir David King as our today's speaker, who might have answers to at least some of the questions. David was born and educated in South Africa. After his PhD, he moved to the United Kingdom, where he had an impressive academic career. In 1988, he was appointed Professor of Physical Chemistry at the University of Cambridge. From 2008 to 2012, he was director of the Smith School of Enterprise and the Environment at the University of Oxford. David has published over 500 papers on his research in chemical physics and on science and policy. He was the chief scientific advisor to the UK government and head of the Government Office for Science under Prime Ministers Tony Blair and Gordon Brown. In that time, he raised the profile of the need for governments to act on climate change and was instrumental in creating the £1 billion Energy Technologies Institute. During his tenure as chief scientific advisor, he raised public awareness for climate change and initiated several foresight studies. He was appointed the Foreign Secretary's Special Representative for Climate Change in September 2013. From 2013 to 2016, David was the first chairman of the Future Cities Catapult, a government-funded body conducting research into smart cities. In his role as scientific advisor to the UK government, King was outspoken on the subject of climate change, saying, "I see climate change as the greatest challenge facing Britain and the world in the 21st century." Getting back to the action himself, David founded and chaired the Center for Climate Repair at Cambridge. So, David, can we repair some of the mess we made?
Peter, thank you very much for your very warm introduction. I'm very grateful to you, and I'm delighted to be speaking at this Asia Society talk, the OIST. I'm going to, first of all, say a little bit about the arrival of that final agreement reached by the United Nations Framework Convention on Climate Change in 2015. I think that it's fair to say the British government played a very heavy role in the achievement of that agreement, and I was in the driving seat in the previous 3 years to the 2015 agreement. What I would like to say is I was really convinced at that point in time that we should be aiming for no more than 1.5 degrees centigrade above the pre-industrial level if we were to avoid a series of catastrophes around the world that would begin to make our civilization look very difficult to continue to exist. At this point in time, I've got to say that I've had to change my mind. And the reason is because the understanding of the risks of climate change means that we are already in the place that I was hoping we would avoid. And the reason I'm saying this is because there's very little discussion at the moment about the so-called tipping points in climate change. There's a group of scientists who have been led by Johan Rockström and by Peter Linton in the UK, set out about 15 tipping points and saying, once these tipping points go, the next tipping point becomes very vulnerable, so it's like a bunch of dominoes. And the first tipping point I'm going to be telling you is now very much in danger of going. So in this presentation, I plan to set out the clear risks that the world is now facing and going through, and how this is only going to get worse as we get further into the future. But I will also then be setting out a detailed strategy. I left government in 2017 to come back to the University of Cambridge and set up a Centre for Climate Repair. So in a way, I'm going to explain why I have set up a Centre for Climate Repair and what its objectives are. It is acting as a global hub. I also want to say bilateral agreements between countries are critically important. Yes, the UNFCCC process is important, but I'm going to emphasize the importance of bilateral agreements. In the run-up to Paris 2015, I made 96 official country visits. I had built up 165 climate attachés, climate experts in our embassies around the world. No other country did this. It's the bilateral agreements that produced that result in 2015. And well, by the time I arrived in Paris, I knew there would be an agreement. So let's move on. What I'm first of all going to take you to is the state of the world in terms of greenhouse gases at the moment. And I have to correct a very common misconception here. 260, 270 parts per million is the pre-industrial level of greenhouse gases in the atmosphere, and of course most of that due to carbon dioxide. And as we move forward in time, you see in blue the carbon dioxide level alone, and the total in black and red, two different estimates. The total is well in excess of that figure. And the reason is because the carbon dioxide has now been joined by methane, particularly, but other NOx gases, for example, that are greenhouse gases. And methane is roughly 130 times more effective as a greenhouse gas per molecule than carbon dioxide. And so what we see is that today we are in excess of 500 parts per million. We are rapidly approaching a doubling of the greenhouse gas level. And this is really rather like when you get into your bed at night, you put a duvet over yourself to get warm, to stop your radiated heat going out, just as our radiated heat goes out into space from the Earth. And if you then put another duvet on on your bed, you would feel far too hot. And so the net result of doubling the greenhouse gases, quite simply, is that we will become far too hot, or at least the temperature change and other changes in our weather systems will become unbearable compared with the climate systems that we're all used to and have got living in around the whole world. Here's one of the consequences of what is currently happening. Last summer, I'm talking about 2021, in that summer we had serious extreme weather events of a kind never observed before around the whole of the Northern Hemisphere. And the newspapers tended to report these as if they were almost accidentally all happening at the same time. I have set up a group called the Climate Crisis Advisory Group, composed now of 16 individuals from 12 different countries. This is the world leading group on climate change. They are all climate change experts, all recognized globally as climate change experts. This group is able to respond in a very agile fashion. Many of them are senior authors of the IPCC reports, but we are able to respond in a much more agile fashion. And so we produced a report on the extreme weather events around the world last year, and we produced it at the end of August. Now, what I'm going to say is we were able to attribute these events to one of the tipping points that has now begun tipping, and that is the melting of ice over the Arctic Sea, exposing the blue sea below the ice, that used to be below the ice, to sunlight during the polar summer months. The 3 polar summer months are the period when eventually 24 hours of sunshine, and the sun's energy is soaked up by the blue sea, whereas, of course, the ice that was sitting over the sea for many hundreds of thousands of years was reflecting the sunlight back into space. This means that the North Pole itself, during those 3 summer months, is now one of the warmest regions of the planet. Now, the next slide, this slide that you can see now, is showing you the average temperature in black for the whole planet. And there you see the temperature rising to about 1.3, 1.35 degrees centigrade above the pre-industrial level. That's where we are on average for the whole planet. But in red, we show what is happening on average for the Arctic Circle region alone, and this is the annual average temperature. You'll see that the Arctic Circle is now heating up at roughly 4 times the rate of the rest of the planet, and the temperature there is now about 3 to 3.5 degrees centigrade above the pre-industrial era. The consequences of this massive increase in average temperature around the Arctic Circle region, and in particular the very severe temperatures in the summer, are very severe in terms of what happens around the whole planet. And I'm just going to expand on that statement as I move forward in time. But let's just seriously take in the graph that I'm showing you here, because it all began about 15 years ago. This was the period when the blue sea began to appear every Arctic summer period, and now we have something like 50% of the Arctic Sea exposed to sunshine, and the North Pole, as I said, is one of the warmer regions of the Northern Hemisphere, 20 degrees plus being observed at that point. The key parameter I want to get across now is the jet stream. And on the left-hand side, you see the classic position of the jet stream, not absolutely circular as shown here. This is an idealized picture, but never far from circular. And this is a very strong wind. It's a wind that blows anti-clockwise around the North Pole, and that wind separates out the cold air in the Arctic Circle region from the warm air from the equatorial region. So marked L here as the cold air, and marked H is the warmer air in the tropical regions. And that wind has meant that, for example, the UK is rather warmer than it would otherwise be. Now, it is based on the fact that the coldest region is around the North Pole. No surprise there. On the right-hand side, what we see happening, and this is what is happening during the polar summer months, the 3 months of the polar summer, we see that the warm Arctic, and above that Arctic Ocean, the air is now warming up rapidly, and above the Arctic, that low-density warm air is pushing the cold air down. So you'll see that the cold air going down over, in this picture, North America. This is actually a record of the position of the jet stream during a particular period in time a few years ago. So you get this Central American area very cold, and then the warm air. Of course, we can't have a vacuum in the atmosphere. Warm air coming up from the tropical region and moves up north to replace the cold air that has moved down south in another region. Now, this is what is disturbing the climate systems of the Northern Hemisphere in particular, but it doesn't restrict itself to the Northern Hemisphere. So these are the schematics I wanted to show to demonstrate the importance of the Arctic, this wind that blows around the Arctic that we call the jet stream. Now, this is actually what happened to the jet stream over North America last summer. What we find is that the jet stream is running from south to north along the coast of North America. And in Central America, we find the jet stream dropping down, and so we get the jet stream now blowing from north to south, whereas before from south to north. And so instead of being circular, it's very seriously distorted. And the position I'm showing in this diagram, the jet stream got locked in that position for a few weeks. And the result was the highest temperatures ever observed, not the highest by 0.1 degrees centigrade, but by 5 to 10 degrees centigrade in these regions of the world. Lytton in British Columbia famously hit 49.9 degrees centigrade. More interesting, perhaps, is that this is an area of the world where very few people have air conditioning because it's not a very warm part of the world. Canada isn't that warm. And as a result, because people cannot survive at these temperatures without air conditioning for very long, about 135 people died in this very upper middle class town in British Columbia. On the other hand, down the center of America, very cold air. Some of you might have heard Texas recording temperatures minus 13 and then even minus 16 degrees centigrade. Snow in Texas, never heard of before. So the cold air coming down from the Arctic being pushed by that warm air, and that distortion leads to very stormy weather around the jet stream. The jet stream is still a very strong wind. It is being weakened by this distortion. This is showing a general picture of what is happening as a result of the melting occurring in the Arctic region. So on the left-hand side, I'm simply showing the blue Arctic Sea, and this is a real-life version of what has happened there. A satellite, but drawn up picture from satellites. And what you see is the blue ocean is now along the coastline of Greenland as never before in our history, in the civilization's history. And so as a result, Greenland ice is now melting irreversibly. And I'm quoting there the IPCC. This isn't a newly discovered phenomenon. Greenland ice is now melting irreversibly. And what does that mean? When all of the Greenland ice has melted, global sea levels on average will have risen by about 6.5 meters. And quite clearly, well before that time, we would have lost the ability to live in many, many of our coastal cities around the world, if not all of them. So what we see here is a potential danger to the longevity of our civilization. That level of sea level rise may take a few hundred years, But what would 2 meters sea level rise do? What would half a meter sea level rise do? Already these would cause very significant chaos, and I'm going to come back and emphasize that point in a moment. But remember that no country, except the landlocked countries in the center of large continents, will be free of the direct consequences of this, and the indirect consequence no country would be free from. The center slide is just showing what I've been talking about, the meandering of the jet stream, and I've already talked about the extreme weather events, which are not restricted to the Northern Hemisphere. But let me quickly say what happens at the North Pole is very different from the South Pole. The North Pole is an ocean surrounded by landmass, and on that landmass is permafrost. The South Pole is land surrounded by oceans. Antarctica is a large continent, and that is where the ice is sitting. As the ice on Antarctica melts, of course, it enters the ocean. That 6.5 meters of sea level rise from the melting of Greenland ice has to have added to it the further 3, 4, 5 meters from the loss of ice from Antarctica. So this is an underestimate of the final rise in sea levels globally. On the right-hand side, we've known for some time that there's a vast amount of methane trapped in the permafrost in the Arctic Circle region. That permafrost contains methane in the form of methane hydrate, and methane hydrate decomposes below the melting point of ice. Some of that decomposition has been observed for many years. In some areas of the permafrost region, you can throw a match onto the ice and you find you get a beautiful blue glow over quite a large region of the ice around you. Now, that situation is now changing quite dramatically with the explosive release of methane. Methane in the atmosphere has a half-life of about 10 to 12 years. And for this reason, people have tended to underplay the importance of methane in the atmosphere. So if I just draw an analogy with a bathtub and water running out of the bathtub and water running in, the rate is such that after 10 to 12 years, half of the bathtub is empty if there's no more methane emissions. But if the methane continues to flow in, if the water continues to flow into the bath, and it flows in faster than it's running out, of course, methane rises in the atmosphere, and that is giving rise to this very severe temperature change earlier than we had anticipated. We really ignore methane in the atmosphere at our peril. If we get explosive release of this methane in large quantities over a period of maybe 20 years, we could see temperature rises in the region of 5 to 8 degrees centigrade or even more. So this is really a very big challenge to the comfort of our human species as we go forward. None of this is good messaging, I realize, but I hope to come back with a better message at the end. Next slide, please. Where are the regions most at risk? And I'm going to immediately say, well, Southeast Asia doesn't look too comfortable. The left-hand side is a projection for the land underwater at high tide in Vietnam. Now, the Mekong Delta has been formed over many hundreds of thousands of years. Silt brought down by the Mekong River means that that delta is all based on silt being brought down by that river, and the whole of Vietnam is built on that delta, and the country is therefore very close to sea level. So if we just take into account the understanding of sea level rise before what I've just explained to you, we get the presentation on the left-hand side. This is the once-a-year flooding simply at high tide. So this is the highest tide of the year. And what you see is that a significant proportion of the Mekong Delta region is underwater once a year. That's seawater, and that's where a very large proportion of the world's rice is grown. The biggest rice paddy fields in the world are in Vietnam. On the right-hand side, the same research group have republished this estimate based on a reanalysis, and you'll see a much more frightening situation where about 90% of the landmass of Vietnam, including a large proportion of Ho Chi Minh City, goes underwater at least once a year by mid-century. That's less than 30 years from now. Rice production may continue if we can produce saline-resistant rice in time, and the Rice Research Institute in the Philippines is busily working on that. If we can produce it in time. If not, of course, we lose a very large fraction of the rice production in the world. This is the third biggest area of rice production in the world. But of course, sitting across from Vietnam is Indonesia. Many of you will know that the Indonesian government has now decided to move its capital to higher ground because, for example, Jakarta last year in 2 months was effectively underwater. So the rising sea levels are already challenging this part of the world. Indonesia is an archipelago very close to the sea, and a large amount of rice paddy fields are also close to the sea, and in southeast China the same. And what you can see is not only population movement, massive migration following further rise in sea levels in this region, but also massive loss of food production for the whole world. And here is the explosive release from methane from the permafrost region of northern Siberia. This was an explosion. That crater that you see there measures about 50 meters in diameter and about 60 to 70 meters deep. It's a beautifully symmetrical, cylindrical hole in the permafrost. Now, of course, what you see is green growth around the outside there. The permafrost contains in the surface area a fair bit of earth, and so there's a fair bit of growth occurring there. You will know there are forests that grow, arboreal forests that grow in the permafrost. People living on the permafrost about 250 kilometers from where this explosion occurred reported this to the Russian government. I believe they thought this was explosive tests by the Russian government themselves, but the Russian government knew they weren't doing that. They sent Academy of Sciences scientists over to explore it, and this is what they found. How many of these explosions have now occurred? About 1,000, it could be more. So it's the permafrost in that region is becoming pockmarked with these explosive releases. Of course, the contribution to greenhouse gases from these explosions is not large enough at the moment to be worrying. But those deep holes there all evaporate, except for the earth in the permafrost, all evaporate into the air. The ice evaporates as water vapor, and of course the methane as gas. So what is happening? A large bubble of methane evolves from the methane hydrate underneath the surface of the permafrost, and when the pressure in that bubble exceeds the weight of the permafrost above it, it's released explosively. So there's the big fear that we may see a very large set of explosions occurring rapidly. If methane is produced very rapidly, just as you turn on your tap very hard in a bath, then it's going to fill up to overflowing very quickly. And that's the worry. Slow release we can take up to a certain point, but rapid release we can't. Now the question is, what do we do about this? Here's the definition of climate repair. We have here set out ourselves as a hub, and we're working globally. And the idea is to work with research centers, with governments, with political people, but also with businesses and financial communities, to see that we have a comprehensive strategy to manage the climate crisis going forward. Now, here's the three elements of the strategy. First of all, deep and rapid reduction of emissions. There is no choice for us at the moment. 40 billion tons a year are being emitted. Now, from what I've told you, I hope everyone can understand, there is no carbon budget left. We have already put too much in the way of greenhouse gases up there. Every ton of greenhouse gas we emit today will have to be removed to create a manageable future for humanity. And I mean every word of that, which is why I'm spelling it out carefully. Every ton we emit today will have to be removed. So this is rather like a country that is in deficit economically, but then it decides to trade its way out by spending further money, creating a bigger debt in order to manage the future. We are simply creating a bigger debt of greenhouse gases in order to manage our future. Deep and rapid emissions reduction has to be, in my view, an orderly transition. It shouldn't be that oil and gas and coal companies are simply shut down overnight. We have to have an orderly transition so that humanity is not impacted by it. This orderly transition really requires cooperation between the wealthy parts of the world, such as the United States, Europe, Japan, and so on, and the less wealthy parts of the world. The parts of the world that I'm talking about, particularly today, are in Africa, but also in other parts of the world. We need to be pulling together on this in a way that we haven't managed yet. And I'm pushing for a group of nations, willing nations, to get together on this project and sort out this orderly transition as quickly as possible. Net zero by 2050 is a starting target, and all of us would like to see us achieve deep and rapid emissions much more rapidly than that. The second part of the strategy, remove excess greenhouse gases that are already in the atmosphere and any further greenhouse gases we emit from today. That means we have to create vast new greenhouse gas sinks to remove excess greenhouse gases from the atmosphere. The centre that I've set up here in Cambridge is focused on remove and the next one repair. There is a significant amount of work happening on the reduce front, but the political need for orderly transition means that we need a much, much more clear strategy for governments to follow to manage that program. Repair the North Pole regions and ice on land. That's the third part of the strategy. Now, what's the point of this? This first tipping point is now tipping and tipping rapidly. As we proceed in rising temperatures, we can anticipate that the remaining ice on the Arctic Sea during the Arctic summer will disappear. How do we manage to restore and manage the ice over the Arctic Sea to see that it keeps reflecting energy back into space? The whole world cannot stand by and allow this to continue. And I say this not because we've got this whole set of tipping points. Once one goes, the next goes. But also because simply what's happening in the Arctic Circle region is challenging the entire planet. Rising sea levels, rising temperatures, and dramatic changing of our weather patterns around the world. So let me say, refreezing the Arctic during the polar summer months is a major challenge, but we are working on that. And again, we have a large consortium working on that. International consortia is the only way forward. So agile international political and financial action, absolutely vital in this whole process. This is my best example of a group of willing nations acting together to see that we can make a way out of our crisis in a good way, and in which we create wealth as we manage the crisis. And the idea, and this was an idea I set up originally when I was in the Foreign Office, the idea is the willing nations should promise to spend $30 billion by 2020, 2021 a year of public money on clean energy research, development, and demonstration. So the idea was that we would de-risk for the private sector all of these opportunities arising from the defossilized world of the future. And I'm very delighted to say, and this was a great moment for me, as you might imagine, and I traveled the world trying to get heads of governments to join this program. The key was when Obama agreed, he's standing in the middle of this picture, to stand under this. We set up outside the COP negotiating process on the first day of COP21 COP21 in Paris in 2015. We set up this banner and invited heads of governments to stand under it if they would follow this commitment. And of course, you'll see that Japan was there, but in addition, the United States and Europe, and then critically we had China and India on board. It was a very broad group of representatives of the key nations of the world. And these nations together have now added 3 more. We've got 25 nations on board, representing about 80% of global GDP. That's the kind of willing nation group that I believe is necessary to drive the program through that I've just been describing. And when I say necessary, this is, I hope you've seen, a necessary program. Bill Gates is standing there next to the President of the United States, Obama, because he rang me up. He said, it's a brilliant idea, and I'm going to back it up with my own private money as an investment into the new technologies emerging, and he has delivered on that promise. Critically important, he understood this was de-risking the opportunities for the private sector to take these new technologies into the marketplace. I've just got a moment left, so let me quickly say, my favorite intervention for removal of greenhouse gases at scale and also for recovering the ocean mammal, fish and crustacean population is marine biomass regeneration, a program that we initiated here in Cambridge about a year ago, and it's a program that is now flying very rapidly. It imitates natural ocean fertilization processes, creates a green layer of phytoplankton, and I can explain that in a moment. And the calcium carbonate deposition largely and other carbonates into the ocean crust firmly sequesters the carbon dioxide. Now, what I do want to quickly say is this all follows a recent understanding of the key function of baleen whales in the biomass of the oceans. The baleen whales feast on krill about 300 to 500 meters below the surface of the ocean. This is the reason they have such massive blubber. It keeps them warm. It's also the reason why they have such massive lungs. They can stay down there for a very long time. The whales will stay down there. The krill is a social animal. It tends to hang around in clusters of perhaps 1 billion. And the whales sail through these clusters with open mouths. The whales live on krill. The krill is a shelled animal. Those shells, of course, drop to the bottom of the ocean. So this is a positive process. But more than this, we know the whales have to come up for air. It's very obvious that function. But they also have to come up to defecate. And the reason is that when they're 300 to 500 meters below sea level, their orifices are all jammed shut by the high pressure of the ocean. So as they come up for air, they also defecate. We've now got a bunch of photographs showing this process. Here is one where you can see the whale feces spreading amongst a pod of whales as they come up. Now, very often, that will create 1,000 to 5,000 square kilometers, because these pods are large, of fertile material in the sunlit surface of the ocean. And within 3 to 4 days of that, this whole area is covered with phytoplankton. We follow this with satellites. And phytoplankton is the initial foodstuff of all fish larvae. When the fish larvae hatch from eggs, they need phytoplankton. The vast majority of fish larvae die. Every form of fish is in the same place. They die if there's no phytoplankton available. And so in these green forests created by the whale species, within a month you might have 500 million fish. So the fish also are feasted on by larger fish, etc. This whole area becomes a living forest in the ocean. And what we are therefore focused on, if I could have the next slide, is using this function of the whales as a means of stimulating us to develop artificial whale feces to put on the surface of the ocean. And as we do this, we immediately create, of course, phytoplankton. And the net result is recreating a fish population and, of course, a krill population. I want to emphasize krill is also formed in this phytoplankton area. And so the net result of all of this ought to be, if we can conduct this across the world's deep oceans at scale, we could recover the fish, mammal and crustacean population back to where it was 300 to 400 years ago, before we discovered whales had this amount of oil substitute, if you like, in the form of their fat. And we were not catching whales initially for their meat at all. We were simply catching them for their blubber. This was the first form of oil well before the discovery of oil. These blue whales, I'm showing you a blue whale here, are now at about 1% of their original population. And most of them are now living during most of the year in the Southern Ocean around the Antarctic, where they maintain a relatively high krill population. The rest of the planet's oceans is very, very devoid of krill, and so they are really stuck there. We can have a discussion about this if necessary. Next slide, please. I'm just setting out here the timeline. You'll see that we have set out a consortium composed of people from India, the United States, South Africa, involved in this. They can work in all of the big oceans of the world, and we hope to be able by 2027 to have completed the research, to have legal permission to carry this forward. And if this program works, I believe after a while we can sit back and let the whales continue the function that they used to have. Next slide, please. I am rapidly coming to an end. People often ask me, how are you planning to refreeze the Arctic? And the answer is by creating white cloud cover over the Arctic. Here, once again, we are mimicking natural processes. White clouds are created when there's a wind at sea, creating tiny droplets of seawater. Tiny droplets of seawater lose their water quite rapidly, and you're left with a tiny ice crystal, maybe a nanometer across, not visible by eye. That's picked up by upward streams of air over the warmer ocean, and you get a big dust cloud of the sodium chloride crystals, which quickly attract water again, and there you have a white cloud. Tiny droplets of water means you have a white cloud. So we're designing devices. This is one design by a marine engineer to see if we can create this process artificially. These vessels you see here would be remotely operated, picking up energy from the movement of the ocean and from wind in order to run these pumps. And we would need to surround the Arctic Circle with about 1,000 of these. We'd obviously have a lot of building up to do until 2027 to complete field trials, and then we can begin rolling this out. And obviously, we would anticipate all governments to contribute to the cost because of the cost of Not doing this is allowing sea levels to rise to unconscionable levels. I've reached the end, and I just want to thank you for your patience, and I'm looking forward to an exciting panel discussion. Thank you.
So, David, thank you very, very much. I think judging from the looks of the people here in the audience, there's a lot of awe. So, thank you very, very much for pointing out the realities. Focusing us on the tipping of the tipping point, and also for your constructive proposals on what possibly innovation and global cooperation can actually do about that. Now, before we go into a panel discussion, I would like to introduce Arima Sensei. Arima Sensei, you can see, in the handout here, has a very distinguished career, on energy policy from within the Japanese government at the highest level there, and he's now a professor at Tokyo University. And Arima Sensei, without further ado, what do you make of the talk, and what are your own thoughts on the topic?
Thank you, Jesper. And first of all, I'd like to pay great respect to Sir David King for his presentation. And in particular, the last part of his presentation, marine biomass regeneration, intrigued me a lot. And from my side, Sir David's very much important point is reduce, remove, and repair, and reduce rapid and also deep emission reduction. And I'd like to depict some challenging part of the deep reductions in the current economic and geopolitical circumstances. And first of all, this is gap report prepared by the UNEP. And in order to achieve 1.5 degrees pathway, there could be a huge gap at the time of 2030 between 29 gigaton to 32 gigaton. And by the way, China's total emission is 10 gigaton. So we need to, say, remove 3 Chinas from the atmosphere to achieve this additional emission reduction. And now we are talking about 45% reduction from now to 2030 for keeping track to 1.5 degree pathway. And in 2020, we have seen 5.8% reduction of this energy-related CO2 emissions, obviously because of COVID-19. And already we have recovered that emission in 2021. Actually, it has reached historic high. And in order to achieve 45% reduction, we need to reduce 7.3% per year, every year, from now to 2030. Much deeper emission reductions compared with COVID, which resulted in, say, a lockdown of the economy and massive energy consumption reduction and so on. So we need to first realize the magnitude of the challenge we are, say, facing. And also looking at the emission trend, obviously Asia has a key whether or not we can achieve 1.5 degrees Celsius target. And then among Asian countries, while we would see the peak out of Chinese emissions around 2030, but for India and ASEAN countries, we will probably see continuous growth of their emissions beyond 2030. And what makes most complicated is the different priority among developed and developing countries concerning the SDG from 1 to 17. And obviously, we are looking at SDG 13, climate action. But according to the global poll called My World 2030, being conducted by United Nations, we can, by the way, see the country-specific outcome, voting outcome. And in Sweden, where Greta Thunberg is coming from, clearly climate action is #1 priority. In Japan, the 3rd priority as well. But in China, the biggest emitter of the world, the climate action receives only 15th out of 17 SDGs in terms of priority. And Indonesia, most populous nation in ASEAN region, the priority on climate action is 9th out of 17. So generally speaking, in developing countries where the per capita GDP is lower, than developed countries. They tend to put more priority on poverty eradication or no hunger or education, good health, and also job and economic growth. So I think amid these different priorities on climate actions, it would be very difficult to assume that climate change is, without any condition, the #1 priority for all the countries. And then, would developed countries do everything to combat climate change? Not necessarily. This is an outcome of a recent survey conducted by Chicago University. And now, 7 out of 10 Americans believe that climate change is a real danger, and they consider that government should take certain actions. But being asked how much are you ready to pay additionally for monthly electricity bill, the biggest answer was $1 per month, so $12 per year. So if that amount is raised to $10 per month, namely $120 per year, then almost 70% of Americans are opposed to such an additional cost burden. And according to the IEA scenario, which was published last June, the net zero emission 2050, they assume $75 per ton CO2 carbon price for advanced economies in 2025. So if we multiply this carbon price to per capita emission in Americans, then Americans are supposed to pay almost $1,200 per year for achieving IEA's net zero emission scenarios. So looking at, say, political reality in the US, they are now complaining about, say, skyrocketing gasoline prices, and Biden administration is doing everything to cooling down the gasoline prices. So I think political, feasibility seems to be very low. Now, the COP26, thanks to UK's excellent diplomatic efforts, we have come out with a very much ambitious Glasgow Climate Pact. The UK's efforts is, indeed laudable. At the same time, the Glasgow Climate Pact, it seems to me that it has changed the nature of the Paris Agreement based on the very delicate balance between top-down temperature goals and bottom-up NDC setting. And 1.5 degree goal and 2050 global carbon neutral target means we have somehow, put the cap on global carbon budget, as Sir David clearly said. And then that will result in very intensified competition over a limited amount of space, carbon space, between developed and developing countries. So probably developing countries will say that the 2050 carbon neutrality goal by US and the EU and Japan are not sufficient. You should go towards carbon neutrality by 2040, and after that you should achieve net negative emissions in order to give carbon space to developing countries. And in addition, they will claim, more and more financial assistance from developed country to developing countries. By the way, in COP26, Prime Minister Modi of India in announcing India's 2070 carbon neutrality goal, he also said developed countries should pay $1 trillion per year, while the current target is $100 billion. Now, the COP26 said, the countries which have not revised their NDC should do so within this year in order to achieve compatibility with Paris Agreement. And whether China and India would revise their NDC by the end of 2022, I doubt it. They could argue that their carbon neutrality goals in 2060 and 2070 respectively are aligned with Paris Agreement temperature goals. And Glasgow Climate Pact also included the coal phase down language, and probably coal phase out with clear timeline will re-emerge in the future negotiation, and that could also spread to other fossil fuels like oil and natural gas. But that has some incompatibility with current energy crisis, where countries say very much eager to secure reliable fossil fuel supply. And willingness to pay, I have already touched upon. Then climate change issue is not in isolation from geopolitical and geoeconomic situation. So long as climate change is another side of the same coin of energy, and U.S. domestic politics, U.S.-China tension, and energy crisis, and of course, Ukraine war. Now, Ukraine war is raising energy prices. It has been already skyrocketing since last autumn. And what concerns me is because of the, say, mushrooming LNG price, not only in Europe, but also in the Asian region, that could delay the fuel switching from coal to natural gas, which has been considered in many ASEAN countries. And, the coal could stay longer than expected in Asian energy mix. That is a great concern. So this is my final slide. And due to energy price hike and food price hike and stagflation risk of world economy, affordability and reliability of energy supply is the highest priority for many countries, including Japan. Though political narrative about climate change does not change, and this is indeed very strong narrative, but its momentum could be reduced in reality, whether you like it or not. And China and India has been boosting their domestic coal production and burning coal power even before Ukraine war. And gas price hike in Asia could delay the fuel switching in Asia. And China and India are keeping distance from G7 on sanction against Russia because they're interested in procuring cheap Russian energy. And even developed countries are, say, preoccupied with cooling down of energy prices. For example, in Japan, recently, government has decided negative carbon tax on gasoline. And more broadly, divided world, which could emerge after Ukraine war, is not conducive for global collaboration in tackling climate change. I fully agree with Sir David that we really need global collaboration. And actually, climate change agenda has become very much, active in, say, in conjunction with the end of the Cold War in 1990. But now we are moving towards more divided world, unfortunately, and increased military expenses in Western countries could crowd out climate finance for developing countries and discourage their mitigation efforts because their NDC are in many ways conditional to financial assistance by developed countries. China has been benefiting from global climate politics by exporting PV and batteries and EVs to developed countries and coal power plants to developing countries. And access to cheap Russian energy could further enhance their energy security position. And so Ukraine war is a wake-up call for rebalancing energy policies, which has been up to now very much primarily driven by decarbonization agenda, but now energy security is not a free lunch. So we need to, solve more challenging, simultaneous equation, how to achieve energy security and climate mitigation and economic efficiency simultaneously. So in this regard, innovative technologies are even more crucial under this challenging situation. So I'm a great fan of mission innovation, and I admire, Sir David King's initiative for making this happen. And I'm also very much interested in, carbon, the Cambridge Carbon Repair Center initiatives, such as marine biology, marine biomass regeneration. So I'll stop here, and I very much hope that I'd be persuaded by Sir David King that no, you are too pessimistic. You should be more optimistic about the more ambitious actions. So I expect the active discussion. Thank you.
Arima Sensei, thank you so much. And I must say, I love the fact that, I think in the initial remarks, Sir David, you sort of scared us, with all these, the negative forces unleashed as we've moved past the tipping point, but you then made the circle and moved towards reduce, remove, repair, and you brought an element of positivity. And now we've got Arima Sensei, who basically tells tells us, oh, but there's a new reality, the divided world, the new Cold War. So, David, you've had a lot of very proactive, hands-on experience in building global alliances towards climate change. How worried are you about this new reality of the divided world, as Arima Sensei calls it, of actually leading to setbacks?
Of course, one has to be worried, because if I understand what Arima Center was presenting there, it is that there is no hope. I think that is the basic message I've just heard, that we, humanity, really cannot expect to survive in our present form for another 50 to 100 years. So I think it's a very gloomy message. I think the unfortunate message really that I've got to return with is that extreme weather events are now impacting around the whole world, and this is a very important means of understanding. But let me just, if I may, take a few minutes to respond to some of the very important points that have been raised, and all of them rather negative. The magnitude of the challenge, I'm fully aware of the magnitude of the challenge. When we began in Europe to work on this, and I'm going to say we, it means Germany, 1989, introducing feed-in tariffs to encourage people to use any sort of renewable energy, any non-fossil fuel energy to create electricity. Feed-in tariffs initially were an enormous subsidy by government for people to build photovoltaics on their rooftops, etc., and put any electricity back onto the grid at an enormous price advantage. It worked extremely well, and the British government, we in the British government introduced this in 1997 in a slightly different form, and the result then spread across Europe. What we did in this process, no economist predicted would happen. The price of renewable energy, as the market expanded through this intervention by governments, as the market expanded, the price of all of these new technologies collapsed. And when I say collapsed, if we look at light-emitting dimers, these very enormous energy-saving means of lighting up our cities and our houses, light-emitting dimers have come down a factor of 100 in cost. Photovoltaics are still coming down. Initially, if I go right back, the cost is reduced by 50, a factor of 50. Offshore wind in Britain, we became rather desperate because the British people didn't want onshore wind. And we had a big program, which was being wrecked by that restriction being imposed by local authorities in Britain. So we went offshore, and it was going to cost us 3 times as much, we estimated, to get electricity from offshore. Our offshore wind is now more efficient per kilowatt hour produced than any other form of electricity production. And the offshore wind, we brought in marine engineers, ironically from the oil and gas recovery, the marine engineers working on recovery of oil and gas from the North Sea, and they produced massive reductions in the cost of offshore wind, and that was then coupled with Siemens coming in and producing wind turbine blades measuring 110 meters. These are the most efficient wind turbines in the world. We didn't anticipate this, but there we are. And that is now being explored across the world, these large wind turbine blades, which you can deliver offshore, very, very difficult to deliver onshore. So I think there have been so many surprises in this process. What I've just described, and I think that with all respect, Arima Center is missing this point. The whole world has benefited. Right, the cost of renewable energy installation, new installation around the whole world, but particularly between the tropics, has dramatically fallen. So it's at least as advantageous economically as it is to install new coal-fired power stations or new gas-fired power stations. This is a critically important point. So what is the big parameter that is really the battle we haven't won? And that is, you mentioned the United States. You also mentioned nationally determined contributions. This was a a massive turndown in the international negotiating process. But it was the only way we could get Obama to sign that 2015 agreement. If we had an agreement which said this agreement would be imposed on the United States, he would have to take it through Senate and Congress, and he couldn't get a majority there. No president has had a majority on climate change in the United States. And why is that? The power of the lobby system in the United States. Unless we understand this, we don't understand anything. The lobby system, the gun lobby, look at the damage it's causing in the United States. Before that, the cigarette lobby. We now have, of course, the climate lobby. And that lobby has been extremely effective. The estimate is $1 billion a year being spent by the oil, gas, and coal industry on these lobbies to try and denounce the science of climate change. If you ask the American population where they stand, you've seen 70–80% are saying there is a problem with climate change. But this is in the face of this massive control of media by these lobbyists, control of Senate and Congress by these lobbies. So I think we need to understand where the big challenges are. Because if I listen to Arima Sante, I've got to say, perhaps I should just go on to a Greek island and give up my efforts, because there is no way forward if we don't understand the severity of the challenge. A third European war following what is happening in Ukraine and Russia would be disastrous. Would it be as disastrous as what I'm describing to you in climate change terms? Of course it wouldn't. Because what I'm describing means a totally new challenge to the whole of our civilization. And until we all realize this, and until we see that every part of the world is impacted by it already, and this can only get worse, we're not going to get public opinion changed. I'm never impressed, I'm afraid, with current opinion polls. When I started working with Tony Blair, we were up against it. It wasn't that easy. And then people discovered that they found the future rather attractive. And some of you may know that in Britain, where the Industrial Revolution began, and it was all fired up by coal mined in Britain, we no longer burn coal to produce electricity. Right? And our electricity production is now 40–50% from renewable energy sources, and we have plans to see that we get that down to zero from fossil fuel sources as soon as possible. It is all doable, and it really is not damaging to your economy. Now, let me just quickly deal with the developed versus the developing nations issue. At COP26, as at many other COPs for the last 20 years, there has been a very clear development of mistrust between the developing and the developed nations. And I'm glad you referred to this difference between them. The developing nations are pointing a finger at the developed nations, and I think quite rightly saying, you created the problem, now please help us. They're also saying, and what are you doing about it? You're telling us that we should get busy with non-fossil fuel energies and so on. But what are you doing? What is the United States doing? We have failed through having no leadership from the United States on any major issue since 1945. I would suggest United States leadership has been critical. That's why the Montreal Protocol went through absolutely quickly, because we had the United States leadership on that. That's why the United Nations was formed, was led by the United States. We have had no real leadership on this issue from the United States. And apart from state actions, federal government actions in the United States have been very, very poor. Lack of leadership from the developed world has created a total mistrust between developing and developed nations. And I think this really is an allusion to the $100 billion. What you didn't mention is the total sum of public money, which was promised at $100 billion a year back in 2016, which was promised per year at that time, has never exceeded $23 billion. Now, we're not producing on our promises. We're not producing on what we said we would do about climate change because we felt we had to take the burden first. All of that was said in the negotiations. So there is a real lack of trust. We have to recover that lack of trust. And I think that is doable. I mean, what we as a nation have to do, each of us, is show that we are doing the best we can, and now we can persuade others much more easily to follow suit. But we also need to help financially. $1 trillion a year, Modi's pretty upset about, he's lost the trust of the developed world. Who knows? $1 trillion a year, not a lot to pay for the challenges of climate change. Believe me, the extreme weather events I was describing from last summer and the previous summers, just the last 3 summers, but last summer, I believe the loss that will be announced by the insurance and reinsurance industry in the West will be approaching $1 trillion. The loss from climate change events today is already numbering the sort of numbers we're talking about as apparently too large to manage this enormous challenge. And I'm just challenging that. So I think what we need to see is a greater willingness to understand the challenge that humanity is faced with. And unless we understand that, we don't manage this problem. How did I manage to persuade the British people and the British public? And by the way, I had to do that because we're an island nation. And as an island nation, we suffer dreadfully from rising sea levels. Our capital, London, is very much at risk from rising sea levels, but all of our coastal cities and our major cities are on coasts. So I think the understanding of the risks needs to be got across at a national level on every possible occasion. And then you'll get the support that you're looking for.
Yes, thank you very much, Sir David. And your word was very much powerful to me. And at the same time, yes, I totally agree with you that we need to understand the, how can I say, magnitude of challenges. I mean, the risks caused by climate change. At the same time, we need to acknowledge the political and economic challenges which we are facing. And because we are living in political reality, and the current government have to care about the current population, and you don't care about, say, opinion poll. But according to the U.S. opinion poll quite recently, about 60% or 65% of Americans are supporting more oil and gas drilling, and 30% are worried about climate change ramification caused by more oil and gas production. So that is a U.S. public opinion. So whether you like it or not, this is a political reality, and we need to live with that political reality. And well, since I was involved in climate negotiation, and I have been doing such a dirty work, so maybe I might have become too much realist, and I need to have high say ambition and ideal like you. And I think we are sharing the common objectives. That is, please don't misunderstand me that I'm not say total say pessimist, and I don't want my pessimistic say vision will come true. And I very much hope that a situation will change. And in order to make that happen, say renewable energy has already say achieved a lot of cost reduction, as rightly pointed out. But renewable energy alone cannot solve the problem because more intermittent renewable penetration needs backing up of the fossil fuels, and how to cope with CCS, and batteries too expensive, and also such an integration cost needs to be taken into account. And though we have seen massive cost reduction, but adding integration costs may not be say still 100% competitive with conventional power, and also competitiveness of renewables varies from country to country. Though renewable is endowed in all the countries, but the potential of economic exploration could be different. In Japan, we have very much limited land, so our solar power potential could be less compared with, say, India, and our wind condition is not as good as North Sea. And offshore wind, we are putting a lot of high hope on offshore wind, but the offshore wind situation in the summertime is much, much weaker compared with North Sea. So we cannot imagine as competitive price for offshore wind as North Sea. So each country has different, say, constraints. And in addition, under very expensive natural gas prices, I have a lot of talk with Asian energy policy makers, and the key word which they use is affordability of the energy prices. So under the current natural gas prices, they feel obliged to, say, extended use of coal, even though it is, say, very much damaging the climate system, but they may delay the shutting down of the coal power plant. And India, you recall, the India's strong opposition to phase out of coal in the last scene of the COP26. And, they say energy transformation from viewpoint of developed country, it is a switching from fossil fuel to renewable. But for India, for those who do not have access to modern type of electricity, delivery of electricity is a first priority. And so long as they have abundant coal, there is no choice but to use coal. So they could accept the argument of clean use of coal, but they cannot accept the word of total phase out of coal. So how to cope with that political reality? That is the point I'm putting on the table. I'm not saying that we should give up our endeavor for climate change mitigation. And finally, maybe the biggest problem of this issue is prisoner dilemma and the free rider problems. If developed countries continue to go through more ambitious climate mitigation actions, then inevitably they will have a level playing field problems. So that is why the European Commission is now considering carbon border adjustment measures. And I'm not sure whether this CBAM will be a silver bullet for ensuring level playing field between, say, active developed country and non-active developing countries, because that could, say, lead to easily the total trade war between developed and developing countries. And it is a very much high probability, and China and India are united in opposition to this sort of trade-related measures. So how to, say, ensure a level playing field to avoid a carbon leakage, that will be another headache we have to, say, face in coming years. So I will stop here. Thank you.
So David, before you launch into your rebuttal, which I know you look very eager and feisty to do that, but in the interest of time, we've only got about 7 minutes left. If in your rebuttal, the lack of leadership from the United States, what are your interactions and your impressions of willingness to lead from the People's Republic of China?
From the People's Republic of China?
Yeah.
I mean, that's an interesting question, because at the moment, could I just quickly put in one point of response? This is the first time I've been told I'm an idealist and that I'm opposed by a realist. And I frankly find that unnecessary. I would like that statement withdrawn. I cannot tell you how often I have discussed things with political figures around the world, and I believe I'm the one facing up to the reality of climate change. I haven't yet heard Arina Sante addressing the question, how do you manage the transition? All I hear from him is, this is what the current situation is, how could we possibly win through? And of course, that's what I was faced with back in 1997. It looked as if the whole world was never going to move properly on climate change. So I think that's the first thing I want to say. Let me just quickly come in with China. We're in a global situation, and this is part of what Arina Sante is saying, where China has become the target of many, many criticisms. And I think this was all begun with the regime in the United States before Biden. And quite frankly, I have to say to you that I think China has done more on climate change issues than almost any other country in the world, given their situation. if your economy is growing as it was at 12% a year, 10% a year, and you are taking a larger and larger fraction of your community out of poverty, and they're coming into being middle-class people much more rapidly than the world has ever seen before, energy demand goes up very rapidly. Now, they have met that energy demand as far as they can from renewable energy and nuclear energy sources. And I must very quickly simply say, Anisante, don't forget nuclear energy as an alternative to what you were saying, using gas and fossil fuels in order to manage the renewable energy system, which does depend on, for example, solar panels, no energy during when there's no sunshine around. So I think I do want to say China is doing a heck of a lot more. The whole world benefits from the fact that China started rolling out solar energy farms around China, wind turbines around China. They've built more nuclear power stations than all other countries in the world put together. Since this whole climate change debate came up. China, since 2012, has been very focused on this. And if you take a public poll of the people of China, they clearly don't see it as a priority, nor have they in the past. But they have seen as a priority the business of clearing up the air in their cities. And that has helped the Chinese Politburo to manage this program. So I think avoid the criticism of China. China has always said that it will follow the United States in whatever actions they take on the global scene. And once Obama said he would sign the 2015 agreement, China signed. So I think that, quite frankly, raising the Chinese issue is a bit of a red herring. I do think China will deliver, and it always has delivered on its past promises, that by 2030 they will have turned around and reduced total emissions from China, and that they will reach net zero by 2060, but I believe they will achieve that much, much earlier. So I think I just want to leave the issue of China on the table, but if you want to raise it again, please do.
That's exactly what I was fishing for, in the sense of that, you actually have had, given the economic development and the stages of economic development, a lot of action taken in the People's Republic of China, which is sort of being demonized by the absolute amount of CO2 emissions, and that's just completely faulty. Now, in the interest of time, I think we've got room, unfortunately, for only one question.
The world CO2 emission is 4 million tons per hour. How much greenhouse gas can we realistically sequester, and at what time scale?
That's a very, very good question, and a very important statement. 4 million tons per hour is the current rate of emissions. What sort of greenhouse gas capture? But let me first of all emphasize, I'm looking for greenhouse gas capture because we want to see the greenhouse gas levels down to a safe level for the future of humanity, which is 350 parts per million. By the way, I'm talking about the real world, not an ideal world. This is the real world situation. Unless we get ourselves down to 350 parts per million, we can't look further in the future than 100, 150 years. I don't know how many other people care about grandchildren. I do. I've got a 2.5-year-old granddaughter. She'll be 72 at the end of this year. Will she be talking about her grandchildren at that point in time? But currently, if I were to listen to Arima Sante and simply sit back, then I think there is no possibility. So greenhouse gas capture is to bring it down. We have to take down the emissions, not match the current emissions to allow it to continue. And so the emissions withdrawal using marine biomass, this is a byproduct of rebuilding the ocean population of biomass, is roughly no less than 4 billion tons a year, and possibly as much as 10 to 15 billion tons a year. This is from one single process. But remember, the oceans are 72% of the world's surface. That's the real world, by the way. And so as we take into account all of the other means of capturing carbon dioxide, here's a very difficult one. If farmers were to play the practice of no longer using chemicals to kill off all of the living species such as earthworms, we could trap as much carbon in the earth per year as I'm talking about from the oceans, just from increased marine biomass. So I think 4 million tons per hour is doable by greenhouse gas capture, but please remember the idea is that we have to stop emitting the stuff. Otherwise, we just make the problem much more challenging for the greenhouse gas removal technologies.
So, David, thank you very, very much. Unfortunately, we've run out of time. I love this debate. I like the tension in the room, which is very, very good. I think that following, Sir David's, proposals, his initiatives, his realist initiatives, bringing global leaders, bringing global investors together is absolutely exciting. Reduce, remove, repair. So, David, I think that you do still have these monthly sessions, right, from your Climate Crisis Advisory Group, sort of doing the education campaign. And then, of course, the Climate Repair Center that you've recently founded, would be urge everybody to please take a closer look and follow that. So, David, Arima Sensei, thank you very, very much. I also want to thank everybody here in the audience and everybody joining us from overseas or from your remote computers. Thank you so much. We hope that you will join us again at future events from the Asia Society and from OIST. Thank you very, very much. Arima Sensei, thank you very much, Sir David.